suspension system and modern trends in automobile. So in the introduction, we have seen what is the definition for the suspension system. So it is one of the system which is required to suspend front and rear axle, consisting springs and shock absorber. So this is generally provided to the vehicle or the automobile to isolate road shocks which are being transmitted to the passenger or the goods. So these are required to provide. So whatever shocks due to the bounce, due to the pitch, and due to the rolling motion of the vehicle. So there are 3 stages in the isolation of the shock. First one is tire, second one is axle and wheel system, and the body. So whatever leaf spring or coil spring and the damper, that is the second stage. And the last stage, that is seats of the automobile which passenger occupies. So below that springs are provided and some cushion is provided on the seat to give the comfort to the passenger. So these are the 3 stages in which isolation takes place. Then we have seen functions of suspension system. First one is to okay, Sachin, screen is visible due to internet failure.
Yes, sir. Yes, sir. It is visible now.
I have connected another internet.
Okay.
Okay. So these are the functions. Then second one is to preserve stability of the vehicle in pitching, rolling while vehicle is in motion. Then to safeguard the occupant from the road shocks. Then to provide good road grip while driving, cornering, and braking. And most important function of the suspension system and its element is to transfer driving torque to the wheels as well as braking force to the chassis. So purpose of suspension system is to support weight of the vehicle, then cushion bumps and holes in the road, maintain traction between tire and the road. That means it is required to give the good grip to have better traction. Then hold the wheels in alignment, and the bit which was discussing. So you can just see the characteristics of suspension system through 3 major characteristics. Is first one is road isolation, then road holding, and then cornering. So these characteristics, that is road isolation, so that we have seen in detail. So in this first column we have put road isolation as one of the characteristics. And what is road isolation? That we have seen ability of vehicle to absorb or isolate road shock. Then our goal to provide these characteristics because it allow vehicle body undisturbed to maintain its stability while vehicle is moving on the rough road. And how to provide solution to give these characteristics for the suspension system. So absorb energy from the road bumps and dissipate it without causing undue oscillation. So this one is the solution for that. Leaf spring or coil spring along with damper is provided. Okay. Then next characteristics, that is road holding. So again, you should think in the way which we have discussed the first characteristics. So this second characteristics, that is road holding. So here we have put that. Then we need to understand what is this road holding means. So this is the degree to which a car maintains contact with the road surface in various types of directional changes and in a straight line. So while cornering, while negotiating turn, while confronting various suspension movements, that is bouncing, rolling, and the pitching. So there should be a contact or the degree to which car maintains contact with the road surface. That grip should be there. So that is nothing but the road holding. So you can see one example for that, it is given. So again, sometimes weight is shifted from front side to the rear side or from front axle to the rear axle while accelerating, and vice versa while applying the brake. So weight is transferred from rear side to the front side. So weight of the car will shift from the rear tires to the front tires during the braking. So because of that, what is happening? There is pitching, or in other words, car dips towards the road. So front side will move in the downward direction. So that is dip and raise. So this type of motion is known as dive, or in other words, you can say that pitch in downward directions. Already we have seen in theory of machine. So pitching of shift. So whatever movement along transverse axis of ship, that is also pitching, and transverse axis of vehicle. So whatever movement of whole body of the vehicle, that is called as a pitching. Here it is considered as a dive. So the opposite effect, again we are going to call it as Scott. So it is occurred whenever vehicle is accelerated. So that means when speed is increases, so weight shifts from front to the back. So during such situations, so there should be stability, and how it can be maintained. So our goal is to keep the tires in contact with the ground, So there should be proper contact, and because so when wheel gets lifted from the ground, so vehicle becomes unstable. So keep the tires in contact with the ground, because it is the friction between the tires and the road that affects vehicle ability to steer, to brake, and to accelerate. So while steering, there should be proper contact between the road surface and the tire. Then we can steer the vehicle in any of the desired direction. For applying the brake, there should be proper contact, and for accelerating. So in each case, that role holding ability or the degree comes into the play. So how to provide solution, or how to provide this role holding characteristics for the vehicle? Just as a design has very important role in this case. So minimize the transfer of the vehicle weight from side to side, from front to back, as this weight transfer reduces the tire's grip on the road. So whenever weight transfer from back side to front side takes place, so that whatever wheels or whatever tires at the rear side, they will lose the grip. Only more grip will be there for the front tires, and vice versa. When weight transfer from front to back is going to take place, the grip for rear wheels will be more, as rear tires will be more as compared to the front. So to avoid or to minimize the weight transfer from front to rear, side to side, or from back to front. So for that, in the suspension system, we are providing different elements. Such elements we are going to call it as anti-roll or anti-roll or just reaction members. So various reaction members. Again, it also includes the torsion bar, so which is one of the element of independent suspension system for modern car. Then third characteristics, that is cornering. So the word itself is self-explanatory. So the ability of the vehicle to negotiate curved path or to travel on a curved path. So here, while negotiating the turn, there is rolling is going to be takes place. That is basic suspension movement. So that is along the longitudinal axis of the vehicle. So goal to provide this cornering is to minimize body roll. So rolling can be minimized. So what is this rolling? So it is occurred as a centrifugal force pushes outward on the car center of gravity while cornering or while negotiating the curve. So it will raise one side and lower the opposite side. So for again left turn, so it will raise inner side and lower the opposite, that is the outer side. So how to avoid this rolling, or how to minimize this body roll of the vehicle? So this, for that we need to ensure that so the transfer the weight of the vehicle car during cornering from high side of the vehicle to the low side. So just by providing these characteristics, we can give this ability to negotiate the turn without hampering stability of the vehicle. So these three characteristics are very important: road isolation, road holding, and cornering. And these are provided, or solution for these are provided with the help of suspension system, which includes leaf spring or coil spring, damper, or reaction members. So various elements, components are used to provide these characteristics. So this is about a brief regarding characteristics of suspension system, and for that it is provided. So next we need to see about what are the requirements of the suspension system. So the suspension system should have minimum weight, it should have less minimum wheel bounce, minimum tire wear, and deflection consistent with required stability. So suspension system, so whatever suspension elements, lead spring, coil spring, there should be deflection to isolate the shock, but it should be consistent with the required stability. So up to certain limit, they should have flexible in nature, and again stiffness is also one of the requirement that is required to have the better stability. Then the important characteristics important requirement related to the cost, that is low initial cost, again low maintenance as well as low operating cost. So based on the type of vehicle, four-wheeler, six-wheeler, then the heavy duty vehicles, light motor vehicles. So based on that, so this cost is to be considered, and whatever elements are required, based on that it is calculated. So we are providing just by considering its initial cost and what is the maintenance and the operating cost, that is also based on the type of the vehicle. And important requirement is compatibility. So for the vehicle, there are various systems, various components. So basically tire, frame, wheelbase, steering system, and another elements which are required to have the self-propel characteristics. So for that, the whatever suspension system components should be compatible with the tire, with the frame, with the wheelbase and the steering linkage. So in the suspension system, various springs are used. When they get deflected due to the external force of bounce and the pit, it should not provide any trouble to the tire, to the frame, to the wheelbase and to the steering linkage. So whatever suspension system, suppose for car, so generally coil spring is used. For Jeep, on the front coil spring is used, and on the rear leaf spring is used. So based on another components, so whatever system we are using, it should be compatible with the other components of the vehicle. Okay. Then, am I audible?
Yes, sir.
Okay, okay. So another one bit, that is sprung and unsprung mass. So you can see this schematic figure. So this is a tire system shown by spring. So first the stage, then this block represents unsprung weight, wheel and axle system. Then this represent coil or leaf spring, this dashpot or simply damper, which represent shock absorber, or we can call it as a damper as well. And this is This block represent sprung weight, or we can call it as a passenger carriage. So in the one of the slide we have seen there are 3 stages of suspension system. So first stage, shock is isolated at the tire. Second, between this axle and the passenger carriage, there is spring and damper system. And third stage, that is sheets of passenger, below that springs are provided. Now, what is sprung and unsprung mass? So you can see the diagram. Based on that, you can define the sprung mass, and here examples are given. What is sprung mass? So weight supported by the spring, weight supported by the spring, that is nothing but sprung mass or sprung weight. So sprung weight, this is spring, this one is damper, whatever components above spring and this shock absorber, those comes under this sprung mass. So frame, then body, then engine and the transmission system. Now, what is unsprung mass? So the mass or the weight which is not supported by the spring, which is not supported by the spring. So here, this is the wheel and axle assembly. So I will draw here figure. So this one is axle, this is wheel, and this is leaf spring, and this one is chassis frame. So whatever this mass, and here I will draw one shock absorber. Okay, so this chassis frame, above that body will be there, above that engine will be there, and transmission system. So these comes under this sprung mass characteristics, sprung mass category, and unsprung mass consisting of axle and the wheel assembly as well as steering system. So whatever steering knuckle, it should be unsprung, otherwise we are not going to get the proper steering effect if the knuckle will also oscillate. So that's why this is also unsprung mass. So basically this may be asked in MCQ. So sprung weight, weight supported by the spring. Unsprung weight, weight which is not supported by the spring. This is the simple definition, simplest definitions of this sprung and unsprung weight or the mass. So these many components are included in sprung and these many in the unsprung. So you should remember this. This may be asked for MCQ. Okay. Okay. Now let us see basic suspension movements. So just to see what is bouncing, what is rolling, and what is pitching. So this is about bouncing. So whole vehicle body is going to bounce. So you can see This is initial condition, and once it confronts some bounce in the road, this body will have this position. So whatever hatching line or dotted lines are shown, dotted lines, that is the position after bounce. Now, what is this bouncing suspension movement? So basically, there will be one question: what are different suspension movements? So first one is bouncing, second one is rolling, and third one is pitching. So you can see what is bouncing. So simply move up and down repeatedly. So in this case, the whole body or carriage unit will continue to bounce up and down on the springs after disturbance. So once external disturbance via obstacle, so you can see such type of bouncing whenever vehicle is moving on the speed breakers. So such type of bouncing movement will be there. So tendency of carriage unit to continue to bounce up and down on its spring after disturbance, move up and down repeatedly. That is bouncing. Then next one is rolling. So what is this rolling? So rolling is another suspension movement. So you can see this is front of the vehicle, and here you can imagine axis perpendicular to this plane of slide. So this is longitudinal axis. Now rolling of the carriage unit about longitudinal axis. This is important of the vehicle. Here what is happening? One side of the car goes down and another goes up, and vice versa, based on whether it is turning to right side or turning to the left side. Based on that, this movement will be there. So this is, you can see this side is lowered while this side is raised, and in this way vehicle is going to roll. Then next one is pitching. So rolling of carriage unit about transverse axis. So you can see this. So this is again transverse axis. You should consider it is also perpendicular to the plane of this slide, and in this way there is pitching. So three basic suspension movements. One is bounce, one is roll, and another one is pitch. So while designing a suspension system or selecting the components for the suspension system, these suspension movements should be considered. So what is pitching and rolling? So rolling is about longitudinal axis and pitching is about transverse axis. So here, in case of the pitching, so there is one more important parameter or the note, that while selecting the components for the front and rear suspension, so we need to understand the vibration coupling effect. So in order to reduce the pitching, so in the pitching, that front side lowers and this rear side raises, and again vice versa. How to avoid this? Just by studying this vibration coupling effect. And to minimize this pitching, we have to provide component on front suspension system and rear suspension system with different natural frequency. So this pitching can be minimized by providing components of different natural frequency. Okay, so basically we need to see the significance of this pitching moment. So first of all, this pitching depends upon the frequency of disturbances, that is called as a natural frequency. Second important factor, bumps over which car rolls, spacing of bumps and speed of the vehicles. So whatever pitching, so this one is the pitching. So body roll about transverse axis. So whatever carriage of the vehicle or body of the vehicle, it is going to roll about transverse axis. So that depends upon four factors: speed, spacing of external force, that is spacing of bumps or pits, and frequency of disturbances, that is natural frequency. So in connection with this, you can see the important note which is on this slide. The pitching persists for longer duration if the rear suspension has lower natural frequency than front suspension. So what is natural frequency? So it is frequency of free vibration. Once it is excited, so whatever that excitation force will be removed. So generally, just you can take example of any of the suspension element, that is coil spring. Once it is disturbed, that external force is not there. So whatever pitching, what is persisting, that depends upon the frequency of that free vibration. So if the natural frequency of rear suspension is lower than the natural frequency of front suspension, in that case there will be pitching for longer duration. So this movement or body roll about transverse axis, that is the pitching, will persist for longer time. So that's why while providing the suspension system, whatever springs which are provided on the rear suspension, are normally have more natural frequency as compared to the front. So springs with lower natural frequency are provided on the front suspension, and more natural frequency are provided on the rear suspension system. So that will minimize duration of pitching movement. Okay, understood these three basic suspension movements: bouncing, rolling, and the pitching. Okay, am I audible?
Yes, sir.
Okay, so this is about significance of pitching moments. So this may be asked for your campus interview. So whatever important things, so it is mentioned here as a note. You should remember that natural frequency of rear suspension is more as compared to the natural frequency of the front suspension, and this is also asked in MCQ. Okay, now let us see various components of suspension system. So basically two important component or the major components, which includes springs and the damper, or we can call it as a shock absorber. So first important element, that is spring, which neutralize the shock from road surface. So when bounce or external disturbance is there, that external disturbance or the shock will be absorbed by the spring. So it provides spring effect to large extent. So basically initial shock will be taken by the spring. Again, tire is also taking part. So tire provides spring effect to smaller extent, that is first stage of the suspension, isolation of the shock, and friction between leaf spring, which also generates damping effect. So springs are required to absorb or to take initial impact. And second component, that is damper or shock absorber, which provides damping effect. So I will draw here one spring. This is the spring. So whatever impact will be taken by this spring, and because of that there will be compression, expansion of this spring. So oscillation are going to be takes place. Now how to reduce the amplitude of this vibration? So for that there is another arrangement which is provided inside this, and that is called as a dashpot, or piston and cylinder arrangement along with the oil. So that is provided to get damping effect, so to reduce amplitude of vibration, and that will reduce the tendency to continue to bounce. So that is avoided with the help of this damper or the shock absorber. So we'll see a detailed meaning of this shock absorber and damper. So generally shock is absorbed by the spring initially, and amplitude of vibration that is reduced with the help of the damper. Okay. Okay. Now let us see one by one elements or components of the suspension system. So screen is visible.
Yes, sir. Yes, sir.
Okay. So first important element, that is springs. Under that, let us see leaf springs. So this is the actual image of the suspension system provided for the four-wheeler. So this is leaf spring. This one is U-bolt. So you can see the various components for this actual image. So here it is center bolt, which maintain all these strips as a bunch, and these U-bolts, whatever shown in the image, those are required to hold position of this bunch on the axle. So this one is the axle or axle casing, inside which there is powered shaft, and that is going to rotate the wheel. So this is spring hanger at front end, and here you can see the spring shackle. So generally this one is the axle on which such leaf spring is provided. So this is a laminated strips. So this is called as a main leaf, and below that leaves of reducing length. So these characteristics or these dimensions are provided to have flexible beam. So it can have flexible nature by providing such reducing length spring. So this is spring hanger at the front. This is spring hanger at the back, and this one is shackle, spring shackle. It is required to compensate, increase the distance, increasing the distance from this point to this point. So when there is external impact on the wheel, this whatever camber provided, so this is called as a camber. So you can consider this as a reference line or line passing through the one of the side member. So this camber is going to reduce when there will be external impact on the leaf spring. Because of that, length is going to be increased. How to compensate? By this spring shackle which is provided at one of the hanger. Then this one is a rebound clip which is provided to have rebound characteristics. Then this is bolt which is provided. So there is one sleeve. Inside that there will be bolt. So to hold this with spring shackle against spring bolt and lock nut. Then this part, it is called as a spring eye, and this is required to hold spring at front spring hanger, and this is required to hold the spring at rear spring hanger. So here also you can see hanger at the front, and here spring shackle directly they have shown. So remaining part we are going to see in tomorrow's lecture. Please wait for 1 minute.